For those of you who do not know me, my name is Trev Harmon. I've been at Adaptive Computing now for about 5.5 years. Been doing professional services, product management, and now I'm over training. And also, as some of you have already noticed, I am also the one going around taking all your pictures at Moab.Con this year. So, as you see me come by, you have the two choices. You can either give me a great, wonderful smile for the camera, or you can try and hide. Actually, I like either option because both of them produce really fun pictures. Okay, so today what we're going to do is we're going to be talking about, well, basically how understanding your system better so you can get better productivity out of it. Now, unlike the last session in here, it's just me for the whole 50 minutes. So, sorry. You're going to have to put up with me. And by all means, ask questions as we go through, okay? Because this isn't a joint session, and it's just me. Well, we're going to have a little bit of extra time to do that. So as we go through, you have questions, raise your hand, shout out, call me names as long as they're at least semi-appropriate, and we'll go with it, okay? So, remember doing this? I mean, when I was little, going to public school, going to elementary school, I remember doing this an awful lot. It was, okay, we're going to line up to go to class, we're going to line up to go to recess, we're going to, lunchtime. There's lunchtime you had to, where I was, not only did you have to line up, they did it by a test. So the teacher would call out, what's 3 times 4? And whoever could answer it first gets in line first. And then she does another one, and you just kind of go through the room, and depending on how good you were doing that day of where you actually got to end up.
Were you last in line a lot,
No, but
sorry.
I had some friends that weren't. It was kind of sad. Yeah, well, it gave us a lot of incentive to learn our times tables really, really well because you kind of got publicly humiliated if you couldn't do them. Apparently, I don't think they let you do that anymore in public schools here. Anyway, with line up, or as our friends from England would say, they queue, which actually we're going to use that nomenclature because that just feels a little bit more HPC-ish. Okay, so we queue up like this. But have things really changed all that much as we've gotten older? We still do the same thing. We queue, stand in line for all sorts of different types of things. And this kind of got me thinking, and this is going to actually show just how big of a nerd I actually am. So everyone knows the movie Tron, right? So you have this whole big, special world, and all the programs are people. And so I was thinking about this the other day of what must it be like inside the scheduler for HPC? You have 1 million jobs in the queue, and they're all standing there waiting in line. And it's not just that, it's that every once in a while, someone more important will come in, and they'll get to go way up there at the very front of the line, and you're still waiting at the back. It's like when I was an undergraduate, waiting at the back of the queue to get onto the cluster. So I kind of decided that, for us sysadmins, it's probably a good thing that Tron isn't really true because we would probably get lynched by the disgruntled jobs if we were to ever actually go into it. But as you say, this is just kind of part of life. As Dr. Seuss said, we just spend all our time waiting. We're waiting for the train to come, or to go, the bus to come, the plane to go, the mail to come, phone to ring, or the snow to snow, a yes and no, and many, many other things. We just spend all of our time waiting. So, our jobs, this is what they do. So this is our little empathy lesson at the beginning of our lecture, right? Let's feel empathy for our jobs and at least understand how it works. So the big question is in scheduling, who gets to go first? How does it actually decide which jobs go? And honestly, a lot of this deals with the different types of policies inside of the system. And we're going to go through and we're going to talk about how Moab goes through and it makes its decisions, and then how certain policies can affect that. Now, there are lots and lots of policies in Moab. And You know, I probably could have spent the full 15 minutes talking about every single one of the policies and just get the appendix out and just sit here and spend 15 minutes just reading it. So I'm going to skip some. I'm just going to skip a whole bunch of them. But pretty much a lot of them can be grouped into these 4 different areas as far as what we're talking about today. So we have the concept of priority. What's the priority for the different jobs? Then we have future reservations, which could really be expanded into all of the different types of reservations inside the system and how that affects where jobs go. Then we have the placement strategy. So once Moab's decided where is it going to, which jobs is it going to put, it has to decide where are they going to go. And then finally, which is the one we're going to really focus on, is the scheduling cycle. So how many people in here know what their arm pull interval is on their cluster? Okay? Good. I see hands are starting to go up like this, which is good because the first time I only saw one hand go up and went, ooh, I don't know how well this is going to go to talk today. See more hands come up. Yeah. It's okay to have your hands way up in here. Like I said, this is meant to at least be as much fun as we can have at a conference. So here we go. The scheduling cycle. Now this is slightly simplified, but really there are 5 steps that Moab goes through for the scheduling. And this is what it just does constantly. I mean, if you want to know what Moab spends its day doing, this is what it spends its day doing. Going around and around and around. These 5 steps. Now, first things first, RM pull interval. So end up about half the hands coming up saying what they know their interval is. So here's the thing about the interval that you need to know, RM pull interval. This is not a hard fixed limit or a hard fixed time of what the scheduling cycle actually is. Show you a little bit later how you find out what your real scheduling cycle is in your system. RM pull interval is basically your timeout. So every time Moab has to go through and make a series of decisions, it needs to go through these 5 steps. And it does that because it wants to have all the information about the entire cluster so that it can actually make a good decision. It figures that if it's making decisions based on partial data, they're not likely to be optimal. Okay, so there are certain events that when they happen will cause an iteration to start early, or quote unquote early, meaning before what RM pull interval says. There are other times where if it's taking Moab a long time to finish one of these steps for whatever reason, the pull interval may go beyond what your RM pull interval is set to. What RM pull interval is that is your timeout, which basically says to Moab, if you haven't received an event and you're just waiting around, just hanging out, this is when you need to restart another polling interval. This is when you need to restart it. Okay? So, let's go through and take a look at these steps. So the very first step is Moab talks to all of its resource managers. Now for major systems, you may only have one resource manager. Maybe that's Torque, maybe that's Slurm, one of those that's basically handling your workload. So it talking to is actually pretty easy. It goes out there and says, okay, here's the 2 things I need to know. Tell me about the state of the cluster. Tell me about the resources. Are the nodes up? Are they down? How much memory do they have? Blah, 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 all that good stuff. So that's one thing that it asks from the resource managers. The other thing that it asks is, tell me about the jobs. So tell me what jobs you as a resource manager know about, number 1. Number 2, what is their current state? Are they running? Are they idle? If they are running, if there's been any flags thrown on them or events that have happened to them. So that's what goes out and it asks from the resource managers. Okay, like I said, most of you probably have one resource manager, so it's pretty easy and straightforward. Some of you may have 2 resource managers. Maybe you've added in Nagios or Gangly or one of the others to give back more information to Moab. It's a good thing because the more information Moab has, the better decisions that it is capable of making. There is one thing you do need to know about the resource managers, though, in this particular step. This step for the scheduling thread is blocking. So, what that means is if one of your resource managers is having problems, Moab is going to get hung up here waiting for it to respond until it reaches a timeout. Okay, and I'm going to show you in a little bit how you actually diagnose if that's what's actually going on your system. There's a pretty easy way to kind of pinpoint that. But that's one of the things that's really, really important. So, for example, if you have a specialized one that you've built where you're going out and maybe talking to a database to get some information from a database. Well, if that database for some reason isn't responding because the network or file, database handles are all gone or whatever, Moab's going to sit around and wait to talk to it. Okay, which obviously will eventually bubble up to start showing up in some of the other stages of what's going on. So, Moab talks to resource managers, takes all the information that they provided, and it loads all that information into its own internal data structures, which it then uses to go through and make its decisions. Next one. Yes?
How long is this timeout?
I think the default timeout is probably 30 seconds. But depending on how you have it set up, it can, there's some of your operating system things that can affect it as well. So like what the TCP timeout could actually affect it in some cases as well if your resource manager is, say, opening up a TCP connection out somewhere else. Yes?
Does it contact the RMs in parallel, or is it serial?
It's serial. Okay? So that means, well, and even in the cases where, let's say it wasn't serial, it still has to collect everything at the end. So either case, it's like running an MPI job.
I'm just wondering if you had, like, if Nagios were hung up and Ganglia were hung up because the monitoring machine was under heavy load. Are you waiting 30 seconds, or are you waiting the same 30 seconds for both? It sounds like you're waiting
I think you're waiting 2. So like I said, I'm going to show you how we go through and diagnose when that starts to happen, because there's a little bit of an early warning system that starts to kick in before things get really, really bad. Your users might not think that's the case, but before things like catastrophically start breaking. So, any more questions on that before we move on into the second one? All right, stage 2. This is where we are managing the workload, and we're actually going to break this up into 2 different sections. So this first one is figuring out which jobs are going to run. So what Moab does is it goes through and it calculates a numeric priority for every single job that's under consideration for running every single iteration. Okay. Now there is a built-in limit to how many it will consider in any given iteration, but the default there is, I think, around 4,000 some jobs it's going to consider without you going in and tweaking anything. So for every single one of the jobs that's under consideration, it has to go through and it has to calculate what its numeric priority is. So there's all of the different types of priority ways that you can set priority. So priority can be based on queue time. Priority can be based on what the user is or what the group is. It can be based on fair share. It can be based on certain attributes of the job. What size is the job? Where was it submitted? All those different types of things can go into priority. So when you go in to the priority section in your Moab configuration file, you start setting that up. Effectively what you're doing is you're building a priority function, a mathematical function. So, where you go through and you say like fair share weight, or you say cred weight, all those things are building this mathematical function that's going to use to order the jobs. Plug each job into the function, and you get your list. And then Moab starts at the very top of the list and starts working its way down the list to decide which job is going, or to start starting jobs. Starts at the top of the list, says, can I start this job? Yes. Okay, goes out, puts it, goes down to the next job. Can I start this one? Yes. Goes out and starts it, sends it to your resource manager to start it. Goes down the list until it gets to the first job that it can't start. When it gets to the first job that it can't start, what it then does is it makes a reservation for that job out in the next available slot where that job is going to be able to start. Okay. Once it's done that, And actually, if you have a reservation depth set to anything besides 1, it will do it for as many jobs as your reservation depth is set to. So if you have a reservation depth of 5, it's going to take the first 5 jobs that it comes to that it can't start and make reservations for them. Okay? After it's done that, the next thing that it does is then it switches over into backfill mode. And then it works its way down to the rest of the list of jobs, starting whichever ones it can for backfill, depending on what your backfill policy is set to. Okay? So any questions on that on stage 2A?
Kind of.
Yeah. Here, and then we'll go over here.
So how does it know, does it use wall time with the started jobs, where it make a future reservation for that? Okay, what's it based it on as far as knowing to schedule it, put a reservation at the next iteration?
So it's going to base that off of the wall times. Now what that means is if your users don't do a very good job of doing wall times, that reservation may be 100 days in the future. Now the thing is though, is it does this every single iteration.
Okay.
So the next time it comes through and does the iteration, it's going to get rid of those reservations that were made for the jobs, the next available jobs. It's going to get rid of those and it's going to run through the list again. And it will recreate, if those jobs still can't start, those new reservations will get recreated based on how the system has now changed. So that reservation may actually slide forward if some of the jobs ended earlier than what their wall clock had been set to.
So the users specify when you have the default one, I imagine, under fit. They'll just use that, and then at that point, determine the next slot open.
Right. So if the users aren't giving anything and you haven't changed the default wall clock limit for jobs, I think it's 99. Yeah, it's like
forever.
Effectively forever. So it's best to encourage your users to do wall times, and what you can do with that is that you can start off with some really soft policies around it. Because a lot of times what users are afraid of is that if I give a wall time, if I go over my wall time, I'm going to get smacked. My job's going to get killed or whatever. And with Moab, you don't have to do it that way. You can do a hard policy, you can do a soft limit, hard limit. You can set the policy just to be, just let them go over for the first little while. You can also use in the priority functions, there's one of the weights that deals with how good they are with specifying what their wall times are. And so if you don't want to use the stick approach, you can use the carrot approach and say, the better you do it at guessing what your wall times are going to be, the higher your priority is going to go. And then give a positive reinforcement to it instead of just, being the mean sysadmin that they're always trying to fight against and find ways to make your life interesting.
Stick is more fun.
It does, yeah. Arms races are always more fun, yeah. Yes?
So you said earlier that it will go through all the jobs up to some limit, which is like 4,000, right?
Right.
Doesn't the state of the job impact that?
Right. So the state of the job is going to impact that. For example, say the jobs are on hold. It's going to skip those. Those aren't going to be eligible for scheduling. If the job's already running, it's not going to be considering those. So
is there some limit per user? There's not. I heard there's some limit.
Right.
Below which it won't look at their jobs.
Well, what you can do, and this is also going into some of the other things, like I said, this is all about policies. So yes, there are user limit policies that you can set. By default, they're not set, but you can set saying, all users or these certain users can only have X number of jobs running, or can only have X number of processors, X number of nodes. And so any of their jobs that fall outside of that range aren't going to be included in this list of ones that are eligible. Now they can still submit them into the queue and have them sit there, and oftentimes, that's great. Probably want them doing that as opposed to, having to sit there and wait for the job to finish, okay, now I'm going to submit another one. So yeah, you can let them queue up as many as they would like to. But if you have users that are dominating the system just out of the sheer number of jobs they're submitting, then yeah, you can certainly go in and set limits. And so all that goes into this particular stage. Any more questions on this stage before we move on to stage 2B? All right, stage 2B. This is the next part. So after Moab has said, okay, I'm going to start this job, the next thing it has to do is it has to decide, where am I going to put this job out on the cluster? So it does this for every job that has to start. So down here in the lower right, or lower left, I guess from your side, down here in the lower left, we have our cluster. Those of you who are over on the far side over here, we can't really see it. They're just a whole bunch of gray boxes that, well, they're actually servers by shrinking down so small that they kind of look like gray boxes. So we start with all nodes. And the first thing that Moab does is it runs it through a filter. So some of our nodes have gone away. And what the first filter is that Moab goes through is it throws away, quote unquote, throws away all of the nodes that don't meet the physical aspects that are required for the job. Okay? So if they say I need to have 4 processors on one machine, then all your dual cores get thrown away in this first filter phase. Okay, so it goes through and it makes a list of these are all of my nodes that could theoretically run the jobs that the user has asked for. Okay, it then runs it through a second filter. This filter is the policy filter. So it now goes through and it throws away all of the remaining nodes that the job can't run on because of a quote-unquote policy. Now, those of you who have been with us for a while know that we use policy to mean a whole bunch of different things. So here are some of the types of policies that would come into effect here. One of the big ones would be if there are already jobs running on those nodes. Okay, so if those nodes are already have some type of a job running on, obviously we can't start them there, so it gets thrown away. If there are other reservations on there that the user doesn't have access to, then those nodes would also be thrown away. So we basically go through and say, okay, we've filtered out all the ones that can physically meet it. We've now filtered out all the ones that can meet it based on policies. So now we have our list of these are the nodes where we really truly could run this job. So then there's one final step, which is the sort. So Moab goes through and it sorts those nodes and it takes the highest nodes off of that sort, and that's where the jobs then get run. Now, you can determine what that sort actually is. So this is your node allocation policy. So node allocation policy basically determines how is Moab going to sort the eligible nodes to get them out there to run. Does anyone happen to know what the default node allocation policy is?
Is it last available?
It is last available. That is correct. Here, you get a t-shirt. You want a t-shirt? Ooh, almost took out the lights. Yeah, that would have been fun. Okay, so last available. Last available means that it is the reverse order of how the resource manager reports them to Moab. And because most resource managers report things alphabetically, it effectively means reverse alphabetical order. Honestly, I'm not entirely sure why that's the default, other than it does make it nice for new admins or people who are new to HPC, because the jobs always start in the exact same place every time they put them into the cluster. It starts at the end of the cluster and works its way back up. Right, so you can change it to a lot of other things though as well. There's, for example, contiguous, which tries to put the jobs into a contiguous block as reported by the resource manager. There's first available if you want to do normal alphabetical order. You can have it set by speed. There's a number of other ones you can do as well. My personal favorite is priority. So you know how we were talking about you can have a priority function, you write up a priority, or you effectively build a priority function to determine the priority of your jobs. You can do the exact same type of thing with your nodes. Yeah?
Is that going to be visible in 7?
What's that?
Is the priority function visible in 7? You can't actually see what a node priority is at any time. I
think that it's in there, and part of that has to do because the node priority may be affected by what the actual job is that's coming in on it. So there is a node priority where you can go and you can say, this node has a following numeric priority. You can put that on, and that you can already see as part of the check node thing. But that node priority doesn't make any difference unless you use it in your priority function. So if your priority function has the priority item in there, then it's going to take that one into account. Otherwise, you've just kind of gone through and made a nice chart that Moab knows about but doesn't do anything with. It's possible to do that in a number of places in Moab. So, but no priority functions are really, really nice because then you can kind of say, you know, do I want to try and pack them onto machines? Do I want to instead try and spread them out? You know, how do I want my workload to go on? Now, generally, you write one node priority function, which is for every single node in the cluster. But let's say you have a couple special machines that you actually want to be scheduled differently than the others. You can actually write specific node priority functions for those machines. And all Moab does is it just goes through the list of, you know, our nodes here that we have left and says, okay, what's the node priority function for this node? Okay, execute it, give me my number. And so it doesn't care if the priority functions are different, it just cares that at the end it gets a number out and it orders them, highest to lowest. Whoever has the highest priority, those are the machines that it pulls off. And so you can use that in conjunction with reservations or routing queues or other things to do some really interesting workload shaping about where workload actually ends up. Yes?
Quick question. When does it sort the node priorities in the cycle?
The node priority sort happens every time a job goes in to be started.
Oh, so it recalculates every job?
Yes, because, well, it has to. One, because the priority may change. Number two, your list of nodes that you have may change, and it doesn't calculate the node priority for every single machine. It only calculates node priority for the machines that it can start that particular job on. And then the next job that gets started, it may be completely different and may completely change, yeah.
So is the sort also where backfill policy and reservation policy come into play?
Okay, so reservation policy and backfill policy happen, there we go. It happens in the first part of stage 2. So, well, when we say first and second part of stage 2, the second part happens every time a job gets started, whether that job was started because it was the highest priority or whether that job was started because it was backfilled. So, you know, the backfill happens here, and your reservations happen right here on the second, come on, go to my next one, happen here on the second filter. Is where it, because at that point it's saying, okay, here's our list of machines that can physically run it, but some of our policies may, or some of our reservations will then change which ones of those can actually be used because of policy, so that's where reservations come in. All right, good. Any other questions? All right, we're just kind of trucking right along through here. So number 3, refresh reservations. Okay, so we've gone through, we've got our job started. Moab now goes through and it actually rebuilds or reevaluates all the reservations that are currently in the system. Okay, and it does that for a number of different reasons. Number 1, each of the jobs that we've started internally to Moab actually have a reservation. So we now have new reservations that have to be put into play. Also, you know, where you have your reservations that you've given the ability to float around, where you haven't said I want to reserve nodes 1, 2, and 3, but you've said I want to reserve 3 nodes that have their 3 quad cores. Okay, well the jobs that just started may actually affect some of those, or where those are actually being placed to get optimal placement. So I'm just going to go through and it's just going to play Tetris again and kind of restack everything back in nice and neat how it was supposed to be, or based on, not how it's supposed to be, but based on the new information that's now gotten from the resource managers, that it's now gotten from starting all of its jobs. It just goes through, level sets everything again, and we're ready to move on then to the next section. Also, this is also the place where any of your old reservations that have expired, this is where they get taken care of as well. So reservations ended, it gets cleaned up at this particular stage. You have to remember, if I point this way, it doesn't work because the computer's inside the lectern. All right, next one. Update statistics. So, Moab now goes through and says, okay, we have our jobs running, the reservations are all where they're supposed to be. We're now going to go through and just record all of our statistics from this particular, from this particular cycle through. And this is going to be, the amount that it spends working in this particular section is going to be dependent on what you have enabled. So if you've turned off all the profiling, it doesn't have nearly so much to do in here. If you have all the profiling turned on, so you're profiling users and groups and all that type of stuff, then there's a lot more of the statistics that are getting recorded in at this particular place. And then last but not least, at least not as far as your end users are concerned, Moab handles end user requests. Okay? Now, when we say end user requests or user requests, this means every user. So, if the user is an admin, if the user is a normal user, this is the phase where their requests get handled. Now, there are a couple exceptions to that. There are a few of the commands that, starting in the later part of the 6.x series, started becoming non-blocking. Okay, those get handled external to this. So this is talking about the commands that actually have to talk with Moab. So all your statistical commands, and actually the majority of the commands still have to happen here. Okay, so Moab's gone through, gotten this information, started its jobs, refreshed everything. So it basically at this point can say, yes, I know what's going on inside the cluster, so I can answer back with a legitimate answer to what's going on. Whereas if I was to try and answer partway through the cycle somewhere else, we might get some interesting results because things are still in flux. But we've gotten everything level set, start answering questions, and such. Now, if you are using a web portal or any other type of portal or any other type of tool that is talking to Moab, this is also where those requests happen. Okay, so for example, Viewpoint works with Moab. Some of it's in version 7 with web services. A lot of the commands are going to web services, which there is a session going on over there. Not that I'm trying to kick you out of mine. I like you all in mine. So you may want to go and take a look at it later. That helps alleviate some of this as well. But just understand, anything that's talking directly Moab happens in stage 5.
Can you click out the previous slide for 1 second?
Sure.
Thank you.
You're welcome. See, doesn't, I know. Well, the last time I pointed that way, it did work. Where I went back, it just, no. Whatever. Okay. Yes.
On end user requests, what does job submission mean there?
Yes, job submission is an end user request.
Is this
M-sub.
Is that, I mean, I know the job information is a user asks about something, right? QStat, that's where it can get answered, right?
Right.
Okay, but what is job submission?
Well, like when you do an M-sub and submit the job in tomorrow. So,
I see, okay.
yeah. So basically what happens is that, on the other 4 stages, it doesn't refuse to talk to the thing, to the command. Basically, though, it just holds the TCP connection or the socket connection that's come in and says, okay, wait your turn.